Okay, good morning, Bernadette, Billy James, Grisel, and Victor. So, so maybe let's get going kasi medyo kailangan ko maghabol sa Math 151. Medyo we're in week 12 already and I guess I'm still two sections behind the schedule. Pero yeah, don't worry. Try lang natin na mas bilisan ng kaunti ano. Pero I won't sacrifice the details when we are discussing things. So just a quick recap. Last time we talked about actually natapos na natin yung dalawang methods on how to solve non-homogeneous GLDEs. But we noted that whenever solving a non-homogeneous general linear differential equation, say f applied to d applied to y equals r of x, right? Where r of x is not equal to 0, okay, or it's not identical to the zero function, meron tayong ilang mga steps na sinusunod. Actually, there are two general principles that are in play here. First, we need to solve for a homogeneous solution. So we want to find the homogeneous solution y sub c. So when we say homogeneous solution, this is the function y sub c such that f applied to d applied to y sub c must be equal to 0. So in short, sinusolve natin yung homogeneous version ng given GLDE, right? And that's not the big problem, especially if f is a polynomial. So you can just define a characteristic polynomial, find the roots, and then according to the nature of the solutions or the roots, you will have the general solution y sub c. Now, in principle, that should be an easy process. Pero in practice, medyo kapag ka malaki yung degree ng characteristic polynomial, mahirap isolve yung characteristic equation, right? Kasi madali kung quadratic, kasi kung quadratic siya, quadratic formula lamang, right? Kung siya ay hindi na hindi na quadratic, more than 3 yung more than 2 yung degree, then you'll try factoring, you'll try the rational root theorem, or kung alam mo yung cubic formula, kung cubic yung f, then that's fine. Kung alam mo yung quartic formula, that's fine. Pero sabi ng Math 111 nyo, wala nag-exist na quintic formula. Ano, yun yung na-prove ni Galois way back in the 18 or 1600s, I'm not sure. Pero yun, yun yung drawback nito, no, nung method natin na pagka malaki na yung degree ng polynomial, baka mahirap na siyang hanapan ng roots. But essentially, once you get the roots, then you know what y sub c is. Then the hard part is actually the second step, which is find a particular y sub p. So kailangan natin ng isang particular solution to the given non-homogeneous differential equation. So kailangan natin kumuha or makakita ng at least isang function na nakakasatisfy nito. Right? So you need a particular solution for that. And dun sa method na tinignan natin, mayroon tayong dalawang techniques na diniscuss. Una ay method of undetermined coefficients, nakadepende dun sa itsura ni R, yung ating solution or yung ating paraan para paano mag-compute ng y sub p. Sorry. Remember what we did there is to get a function g of d or a differential operator g of d such that g of d applied to r will be equal to 0, and then we have several few steps after that, right? Pero may flaw yung method na yon. Ang problema sa method na yon ay nakadepende kay right-hand side r yung method. Kasi di ba kailangan nating sorry. Kailangan nating mag-imbento ng differential operator g of d such that g of d of r is equal to 0. All right? So kung ang itsura ni r ay polynomial, kung ang itsura niya ay exponential, kung itsura niya ay sine and cosine or linear combinations ng tatlong klaseng functions na yon, then we're good. Pwede nating ma-solve yung entire problem using the method of undetermined coefficients. Kung si R ay constant, kayang-kaya din natin by the method of inspection na diniscuss natin towards the end of last meeting, right? Because once you find y sub p, ang general solution to star is the sum of the homogeneous solution and the particular solution that you have found. Okay? So kaya lang yun nga, may drawback or may limitation yung method of undetermined coefficient. Yun ay mag-work lamang for specific functions R. So ngayon, titingnan natin ano yung pwedeng paraan para ma-solve pa rin or makahanap ng particular solution even though R will not be any of the forms that we have seen before. Kasi kapag ka si R, halimbawa, siya ay cosecant, wala tayong alam na differential equation na merong characteristic polynomial that will give us a solution cosecant x, right? Wala siya dun sa mga forma na kaya nating gawan ng general linear differential equation. Right? So paano natin siya i-solve? Then we can try either the method of reduction of order, which is a special case of the second method that I'll try to discuss today, which is basically the method of variation of parameters. Okay? Pero doon muna tayo sa reduction of order. The reduction of order method that we will discuss here is is specific to second order differential equations, pero this can be applied to higher order differential equations. Yun nga lang kasi ang idea rito, as the name implies, kung siya ay babawasan natin ng paisa-isa yung order ng derivative na nag-appear doon sa ating equation. So in particular, kung nagsimula tayo sa second order, mabababa natin to into a first order differential equation. Tapos masaya na tayo kapag ka nasa first order differential equation na tayo, kasi kapag ka first order na yung differential equation natin, pwede nating isolve yung problem using an integrating factor. Right? So gagamitin natin yung method yung mga methods na na-discuss natin before, specifically the method of integrating factor para ma-solve yung reduced GLDE. So mula sa second order, ibababa natin siya sa first order para magamit natin yung integrating factor method. Right? Para makahanap ng isang particular solution. We'll just need to find one particular solution to this GLDE. Tapos kung ano yung particular solution na yon, i-add ko lang siya sa solution ng homogeneous equation. And that would be our general solution for the non-homogeneous GLDE. Okay. So ganito nag-work, derive natin yung method of reduction of order. Again, we will start with the second order GLDE, pero this will work for higher order, pero magiging komplikado yung proseso. Kasi kung halimbawa, order 5 yung GLDE natin, via the reduction of order, mabababa ko siya sa degree 4, sa order 4, tapos pag order 4 na another iteration of the reduction of order to bring it down to the third order, then another iteration to bring it down to the second order, tapos saka siya magiging linear, magiging order 1, saka pa lang tayo pwedeng mag-integrating factor. Alright? So ganun kakomplikado yung proseso, pero yeah, i-specify ko lang siya sa second order dito. Now, yeah, the reduction of order is designed to find a particular solution dito sa nonlinear GLDE kasi halos kompleto na yung theory natin kung paano mag-solve ng GLDE for any order. As long as CR ay 0. Kapag ka-homogeneous yung GLDE, then characteristic equation lang masosolve na makukuha natin yung general solution. But really, the problem here is how to find a particular solution to the non-homogeneous GLDE, which is required para masolve natin or mahanap natin yung general solution ng non-homogeneous GLDE. All right? So this is how the reduction of order came about. So start tayo sa isang second order GLDE na non-homogeneous. Then I will assume that y sub 1 is a solution of the corresponding equation, the corresponding homogeneous equation. All right. Now, see y sub 1, take note, this is just a particular solution. So siguro to emphasize things, it is a particular solution of the corresponding homogeneous equation. Now, kahit sinasabi ng method of reduction of order, we start with a particular solution, you still need to find the general solution to the homogeneous GLDE. Kasi kailangan natin yung y sub c. Yung general solution, kasi nga later, i-assemble natin yung general solution doon sa non-homogeneous GLDE. Ang form niya ay y sub c plus y sub p. So isosolve muna natin si y sub c, which is the solution, the general solution to the homogeneous GLD. Tapos, pipili ako ng isa sa mga ng isang particular case ng general solution na yon. So remember, yung general solution natin, may mga arbitrary constants yan. You can pick the arbitrary constants to your liking para mas maging simple yung derivation. And that specific solution ay tatawagin kong y sub 1. So si y sub 1 is a particular or an instantiated version of y sub c. Ikaw yung mamimili kung anong arbitrary constant yung gusto mong gamitin. But of course, you want to choose the arbitrary constants para maging non-zero si y1 and at the same time si y1 ay simple lang i-manipulate. Alright? So huwag nyo nang piliin na komplikado yung constants. Usually 1 or 0 lang yung ginagamit natin dun sa mga arbitrary constants to simplify things. We'll see that later, pero yeah, just keep in mind, y sub 1 is a particularized version of y sub c. Right? So ibig sabihin, kung si y sub 1 ay isang particular solution ng homogeneous equation, then this is true. Right? Take note here, tandaan lang natin, si p, which is a function of x, siya yung coefficient ni y prime. Si q, which is a function of x, siya yung coefficient ni y. So really, this is a general linear differential, it's a general linear differential equation with non-constant coefficients p and q for y prime and y respectively. Okay? But in any case, since we are assuming y sub 1 is a particular solution to the homogeneous equation, then this is true. Pag yung mga y's, pinalitan ko ng y sub 1, I'll get this, we'll get 0 as the simplified form. Kasi nga, particular solution ng homogeneous equation si y sub 1. But why do I want to have a y sub 1? Well, we will see here that upon after the substitution, mawawala itong may y na to. Nakita nyo rin later kung bakit gusto kong mawala yung y term. Okay? Now, so I will now suppose, magi-introduce ako ng isang function v. I will suppose that v is a function of x and let y equals vy1. Well, in this particular case, si v ay to be chosen so that how do I put it? So v is chosen such that v y sub 1 is a particular solution of the non-homogeneous GLD, right? So gusto ko ngayong hahanapin natin yung function little v, all right? Ano si function little v such that y sub p is equal to r. vy1 could be our y sub p. So yung function little v of x times the particular solution of the homogeneous equation, siya yung gusto kong maging particular solution. So you can think of it as our ansatz or our guess for y sub p, right? Kaya kung mapapansin nyo, particular solution lang to para dun sa non-homogeneous GLDE, which makes sense because y sub 1 is also a particular solution of the homogeneous version. So ang inisip ko lang dito, baka merong particular solution of the form function of x times a particular solution of the homogeneous equation. So ito yung hula ko para dun sa itsura, o ito yung template. And I'm praying that there is really a particular solution to the non-homogeneous GLDE ng itsura ay function v times function y1. Right? So that's my hope. All right? Now, ano ngayon kung totoo na merong particular solution ng itsura ay v times y sub 1? Well, let's see. Let's first expand or find the derivatives of the function of this function y. I really want to call this y sub p para alam na natin na ito yung final form ko para dun sa particular solution. Now, differentiate y sub p. Makukuha natin ito using the product rule. Again, I needed to apply the product rule here because both v and y sub 1 are functions of x. So I took the derivative of y sub p with respect to x. So kaya nag-product rule ako dyan. And then another batch of the product rule for each of the terms para makuha si y double. Okay? And then since I am hoping that y sub p or this function is a particular solution to the non-homogeneous GLDE, then I want this to happen. Okay? Gusto kong yung y sub p na to, isosolve niya yung non-homogeneous GLDE natin. So that's why we want V to be chosen such that the equation is satisfied by y sub p. All good? Tapos ang gagawin ko sa next slide, ipa-plug in ko itong mga value ng y sub p prime at saka y sub p double prime dito sa buong equation na yan. And I think I just copied over kung ano man yung nandun sa PowerPoint. Hindi ko na siya sinulat lahat-lahat. All right? Pero the idea is this is y double prime or y sub p double prime. This is y sub p prime. Okay? And then this is y sub p. At dapat equal siya sa r of x. Yun yung gusto natin. Gusto ko si y sub p kasi, ina-assume ko ang itsura niya ay v times y sub 1. Then plug it in into your non-homogeneous GLDE. That should hold. All right. Tapos simplify lang. I guess here in the next step, anong mga ginroup ko rito? Ginroup ko yung may mga V, tas may V prime, may V double prime, tas ito may natirang P. So it's just about rearranging terms. All right. Specifically, I group together itong may mga Y sub 1 prime. Because what do we know? Our assumption is that y sub 1 is a particular solution to the homogeneous GLDE. Dahil si y sub 1, nasa-satisfy niya yung homogeneous version ng GLDE, so ibig sabihin this guy is equal to 0. Alright? Kasi yun nga yung assumption natin. Ito yung left-hand side ng non-homogeneous GLDE. Ginawa natin siyang homogeneous GLDE. Nasa-satisfy siya ni y1. So this guy is exactly 0. So magzi-0 to. Matitira na lamang itong mga terms na to. And the nice thing about that, nawala na si V. Natira na lang ay si V prime at saka si V double prime. Okay? So simplify nyo lang. Simplify. Alright? So sinulat ko lang siya na V double prime plus some function times V prime. All good so far? I hope the process makes sense kahit wala muna yung final output in mind. So at least susubaybayan nyo kung ano yung ginagawa ko. Tapos ano yung mga pinipili kong y1, ano si v, and so on. Okay? And then if I am now at this particular point, I can now change the variables. Okay? At dito na papasok yung reduction of order. Because look at this. I have a v double prime and I have a v prime here. Well, hindi pa rin gagana or hindi pa rin siya madaling isolve. Kasi isa pa rin itong non-homogeneous GLDE. Same problem kapag ka si R ay hindi natin kayang gawan ng GLDE na sinusolve niya. So hindi natin kayang gawin yung method of undetermined coefficients. Now, ang kagandahan dito, pwede kong ma-reduce yung order. Kasi ang meron na lamang akong unknown ay si V double prime at saka si V prime. Pwede ko ngayong i-let si W to be equal to V prime. Okay? Para mababa yung order. So itatago ko sa pangalang W si V prime. So si V prime dito, magiging W lang yan. Tapos si V double prime, magiging W prime lang. So I get this equation over here. Now, ano mapapansin nyo dito? Order 1 GLDE na lamang siya. Paano tayo nagsasolve ng order 1 GLDE? Kaya nating mag-integrating factor. Right? Ano nga yung integrating factor dito, if you still remember? So, ito ay solvable using integrating factor. Ano yung integrating factor? Sige nga. Dapat tandaan nyo pa kasi ang galing nyo sa midterm exam, tandaan nyo yung integrating factor, di ba? So what would be the integrating factor here for the first order differential equation in W? Or mahirap pa siyang i-type? Mukhang mahirap siyang i-type, ano? Hindi siya y sub 1, Kiefer. Actually, mas komplikado siya. Remember, integrating factor natin kapag ka meron kayong dy over dx plus p of x y plus q of x equals r of x. Ang integrating factor natin lagi, actually, 0 dapat si q, no? Yeah, kasi dapat na kay r of x na siya. So kapag ka ganito yung ating first order differential equation, ang integrating factor niya ay e to the integral ng p of x dx. Right? So that's our integrating factor. Now, kung ito yung aking first order differential equation, ang unknown ko ay w, first order siya. So ibig sabihin ang integrating factor ko dito ay e to the integral ng p of x y1 plus 2y1 prime over y1 dx, right? Kasi kailangan i-divide ko muna both sides by y1 para maging w prime na lamang yung kasama para isolated si w prime. This will be divided by y sub 1. This will be divided by y sub 1. And the integrating factor, remember, ang integrating factor ay e to the integral of p. So dito ay e to the integral neto. Yun yung magiging integrating factor. So masosolve natin to, mahanap natin si w. Alright? Pag nahanap mo niya si w, tandaan mo lang na yung w na yon ay equal kay v prime. So para mahanap si v, kailangan nating mag-integrate. So integral lang siya ng w dx. Whatever the w that you got. Okay? Tapos pag alam mo na si v, mahanap na natin si y sub p. Si y sub p ay equal kay v y sub 1. Tapos mahanap na natin yung general solution. Yung general solution ay y sub c, the homogeneous solution, plus v y sub 1. Okay? So that's the plan. It sounds really simple, pero in practice, hindi siya ganon kadaling i-perform. Ano? So tingnan natin. It would be clearer if we look at one particular, or if we look at particular examples. So in this problem, we have y double prime minus y equals e raised to x. Kaya nating isolve itong problem na to using the method of undetermined coefficients na na-discuss natin before. Kasi si e to the x, kaya natin yan gawan ng GLDE, right? Kasi dito, kailangan mo lamang ng characteristic polynomial na may root na equal kay 1. So pwede mong gawin ay m minus 1, yung iyong differential equation. So ang g of d mo ay d minus 1. Easy peasy, right? Pero just to illustrate the method, gawin natin dito yon. Alright? So, pwede kayong either undetermined coefficients dito or pwedeng mag-reduction of order. Right? So, I'll just solve this using reduction of order. Okay? So, the first step is to find the homogeneous solution, right? Or the solution to the homogeneous version. So, the characteristic equation. So, siguro sulat ko ng detalye, no? Ng detalyado. So, the characteristic equation for the homogeneous version of, tawagin ko tong star. So, ay m squared minus 1 of star. So, kunin ko lang yung characteristic equation ng homogeneous version equation star, right? So, we have y double prime minus y equals 0. Pag kinuha ko yung characteristic equation niya, kakaroon ako ng m squared, supposedly plus 0 times m kasi walang y prime, minus 1 equals 0. So, m squared minus 1. But the solution here is I'll have m equals plus or minus 1. So therefore, y sub c, or the solution to the homogeneous version of equation star, is a linear combination of e to the x and e to the minus x, right? So it's going to be c1 e to the minus x plus c2 e to the x, and we'll set this aside for later. Okay? So yan yung homogeneous solution. Now, kailangan nating humanap ng isang particular solution to the non-homogeneous equation star para i-add ko yon sa y sub c para makuha yung general solution dun sa non-homogeneous GLD. So kaya lang, ito yung pwede kayong undetermined coefficients. Pero kunwari, hindi natin alam yung undetermined coefficients. Gagamitin ko ay reduction of order. So here, I will choose what y1 is. So I'll just take a particular case of this guy. So in y sub c, we choose pili lang kayo ng kahit anong C1 at C2 na gusto nyo. Pero I suggest you choose C1 and C2 to be simple enough para yung y sub 1 nyo ay simple lang yung itsura, madaling i-manipulate. So in this particular case, I will arbitrarily choose C1 to be equal to 0 and C2 equals 1. Wag lang parehas 0 kasi magiging y1 equals 0. You'll get nothing out of it. Alright? Saka hindi pwede mag-0 si y1 kasi remember, si y1 mag-a-appear sa denominator ng integrating factor. So kaya ayaw natin si y1 ay mag-0. So you can choose the arbitrary constants as long as y sub 1 will not be equal to 0. So in this particular case, with this choice of C1 and C2, then y1 is equal to e to the x. Alright? So yeah, bahala kayong pumili. Pero yun nga, for convenience, ito yung pinili ko na y sub 1. Then we want to find a function v of x. So kailangan ko makahanap ng isang function v of the variable x such that y sub p equal to v of x times e to the x is a particular solution to start. Gusto ko makahanap ng isang function v na yung v times e to the x, that's v times y1, ay particular solution nung equation star. Yan yung gusto natin mangyari. Hanapin si v such that this is true. Now, let's, katulad nung sa derivation natin, I will compute for y sub p prime. Oops. Nangyayari sa screen ko. Ito ay equal sa, i-differentiate lang natin using the product rule. So this is gonna be v of x. Kung nalilito kayo kung sino yung function ni x, sino yung constants, better write v as v of x so that you don't forget that v is a function of x. So I'll have e to the x plus v prime of x e to the x. Tapos kunin natin yung second derivative. Yung second derivative niya ay v of x e to the x plus v prime x e to the x plus v prime of x e to the x plus v double prime of x e to the x. So yan yung second derivative ni y sub p. And then remember, we want y sub p to a particular solution of the homogeneous GLDE. So we want this. Y sub p double prime minus y sub p must be equal to r of x. But so remember, papalitan ko lang to ng y sub p. There you go. Tapos kopyahin ko yung right-hand side na e to the x. Because again, we want y sub p to be a particular solution ng non-homogeneous GLDE. Okay? Then I'll plug this in. So I'll have this guy minus this guy. So sino yung mga mawawala? Hindi pala. So y double prime. This guy minus y sub p. Ang y sub p natin ay eto. So mawawala lang ay yung first term. Tama ba? Yeah, mawawala lang yung first term pagka sinubtract ko sila sa isa't isa because I want y sub p double prime minus y sub p. So this term vanishes, but everything remains, right? So we will have v double prime of x e to the x plus 2v prime e to the x because this and this have the same coefficient. So I'll have 2v prime of x e to the x equals e raised to x. If this looks very tedious to you, you can drop the of x here, but just keep in mind that v is a function of x. All right? Siguro i-drop ko na siya sa mga susunod na mangyayari. All right? But essentially here, all of them has e to the x or have e to the x, and e to the x is never 0, so I can divide both sides by e to the x. So I'll have v double prime plus 2v prime equals 1. A much simpler differential equation. But again, this is still a second order differential equation. To find a particular solution, pwede nyo gamitin uli yung method of undetermined coefficients kasi constant naman yung right-hand side. Madaling kunan si 1 ng GLDE na sinusolve niya. Pero I'll stick with the reduction of order. So dito, maraming branches yung solution. Many possible ways how to solve this equation. Pero para sa reduction of order, I will let V prime to be equal to W. So that, pagka si V prime ay ginawa kong W, si double star, then double star, becomes this equation. So siya ay magiging, lipat na ako sa kabilang page. If you want to get a screenshot of it, so this is your chance. Bago ako pumunta sa next page. Okay na? So, I'll replace V prime by W. So we'll have W prime plus 2W equals 1. Ito na yung reduced order. Kasi from a second order differential equation in Y, we now have a first order differential equation in W. Let's call this triple star. Okay. Now, an integrating factor. First order na to, pwede na tayo mag-integrating factor. An integrating factor for triple prime, for triple star is S of x equals e to the integral of yung formula natin sa integrating factor from chapter 1. Dapat muna ito ay 1 yung coefficient. Alright? Tapos, this guy, ang i-integrate ko, exponent ko siya kay e. So we'll have 2 dx over here. And this is e to the 2x plus c. And then we choose c equals 0. So it will be e to the 2x when c is taken to be 0. We can do this because we're just looking for an integrating factor. Kailangan ko lang ng isang specific integrating factor, kaya free tayo na pumili ng capital C. For simplicity, again, I'm picking C to be the constant 0. Pero in some cases, you can choose any constant C there. All right? All right, so that's our integrating factor. So I'll multiply both sides of double star by the integrating factor. Hence, we'll get e to the 2x w prime plus 2e to the 2x w equals e to the 2x. All right? And the nice thing about the integrating factor that we chose, or kaya natin ganun pinili yung integrating factor, so that this guy will be the derivative, or the left-hand side will be the derivative of e to the 2x times w. But kasi pag dinifferentiate mo to, you'll have e to the 2x times w prime plus w times 2e to the 2x, which is essentially the left-hand side. So na gano tayo, product rule in reverse. Ganon natin pinili yung integrating factor, which I hope you still know from chapter 1. And I know you do kasi tama kayo. Or maraming nakatama sa inyo dun sa midterm problems natin na gumamit ng integrating factors. Okay? Now I can multiply both sides by the differential with respect to x. So magiging d of e to the 2x times w na lang yung left side. Then it would be e to the 2x dx. And then now I can integrate. Then this will give us e to the 2x times w equals, this guy will be 1/2 e to the 2x plus an arbitrary constant d. Okay. Tama ba integral ko? Yes. Okay. Now, remember, what we are looking for is y sub p, isang particular solution. So since we are, siguro note ko dito, since we are looking for a particular little v, kasi ang hinahanap natin ay particular solution ng GLDE, ng non-homogeneous GLDE. Si y sub p ay isa lamang sa infinitely many families, as a infinitely many member ng family of solutions ng non-homogeneous GLDE, pwede akong mag-instantiate ng mga arbitrary constants. Kasi again, ang hinahanap lang natin ay isang particular na v. Hindi natin hinahanap lahat ng posibleng v. Naghahanap lang ako ng at least isang v. So pwede akong magbigay ng value sa kahit na anong arbitrary constant involved in my solution for y sub b, right? And remember, we're still under the second bullet, which is finding y sub b, a particular solution. As long as we are in this second bullet, we can give specific values to the arbitrary constants that we will encounter, just to simplify calculations. Of course, you can keep them until the end. Pero para mas mapasimple yung solution, dahil particular solution, y sub p lang naman yung hinahanap natin, in turn, we're looking for a particular v, pwede ako ngayong mag-imbento ng values ng arbitrary constants, right? And with that particular principle in mind, then we can choose d equals 0. All right? So, habang nasa second bullet, free kayo na pumili ng particular constants na gusto nyo. Kasi nga, particular solution lamang yung hinahanap natin. Okay? So now, thus, we'll have e to the 2x times w equals 1/2 e to the 2x. Kasi nga, pinili ko na ngayon si d to be equal to 0. And then I can divide both sides by e to the 2x. I'll get w equals 1/2 e to the 2x. But remember that w is simply, what is w again? W is v prime in disguise. So ibabalik ko na ngayon si v prime. So w equals v prime. So v prime is equal to 1/2 e to the 2x. But v prime is essentially dv over dx, right? So we'll have dv equals 1/2 e to the 2x dx. Then we'll integrate it to get v. So therefore, we get v equals, in its most general form, it is equal to what? It's equal to e to the, so 1/2, 1/4 nga ba? 1/4, hold on. Sorry, wala na pala to si e to the 2x. O, diba? Yeah. Kaya ako nagtataka kasi hindi familiar na meron akong integral ng 1/2 e to the 2x. Sinolve ko to kagabi. Sana sinabi nyo na si w dapat ay 1/2 lang. Nagsimula na naman ako ng solution na mali. Ano? Kasi dinivide ko nga pala both sides by e to the 2x. So si w na lamang ay 1/2. Tama ba? W equals 1/2, no? Okay. Daya nyo, hindi nyo sinabi na may mali na ako doon. Buti na lang hindi familiar yung integral. Okay, so now, again, replay. So alam ko si w ay equal kay v prime. Kasi v prime ay dv over dx. So ito ay equal kay 1/2. So dv will be equal to 1/2 dx. Then we can integrate. So I'll have v equals 1/2 x plus an arbitrary constant e. But again, we're still at the second bullet of our solution, meaning we're looking for a particular y sub p, which is dependent on a particular v. So we can keep v as 1/2 x plus e, but for simplicity again, we can pick e equals 0 just to make things simple. So we'll have v equals 1/2 x. So therefore, ang y sub p natin ay si v times y sub 1. Sino nga si y sub 1 natin? Si y sub 1 natin ay si e to the x. So ito yung y sub p natin. Okay? So if you want to take a screenshot of this, please do so. Lilipat ako ng next page. Pero final answer na lang naman yung isusulat ko sa next page. Good? Right. And here is the final answer. All right. So ito yung y sub p nating nakuha. This is our y sub p, which is v times y sub 1. All right. So this is our v, the v that we computed times the y sub 1 we chose. Then this is y sub c. Kasi nga, yung general solution ng isang non-homogeneous GLDE ay equal kay y sub p plus y sub c. So this is our final answer. Okay? Any questions? Haba ng solution, no? Imagine doing this on your exam. Kailangan talaga mag-practice. All good? All right. As I've mentioned, you could have used the method of undetermined coefficients here, the one that we discussed last meeting, right? Pero halimbawa, nandun na tayo sa next example na d squared plus 1 y equals cosecant x. Pag inattempt nyo yung method of undetermined coefficient, mas stuck kayo dun sa second step na paghahanap ng GLDE, ng homogeneous GLDE na solution si cosecant x. Kasi wala tayong alam na GLDE with constant coefficients na nagbibigay sa atin ng solution na cosecant x. Kasi nga, nakikita lang natin na solution base dun sa roots ng characteristic equation ay constant, exponential, at saka sines and cosines, and linear combinations of them. Wala tayong cosecant x na GLDE with constant coefficients. So, the method of undetermined coefficients will not work for this particular example kasi cosecant yung r of x. Kaya limited yung na-discuss natin last time. Ngayon, pwede nating itry na isolve to using the reduction of order. Kasi puro integration naman. Ang drawback nga lang nitong method na to, halos puro integration yung kailangan natin gawin. Okay? But nevertheless, let's try to do it. First step, first bullet is to find the solution to the homogeneous version. Okay. So ngayon sketch na lang ng solution ang ipapakita ko. So it's up to you to write the formal solution with all the explanations. At alam niyo na, base dun sa midterm exam, I pay attention to how you discuss your solution. Hindi ako ginaganahan magbasa pag puro equations lang yung nakikita ko na hindi ko na alam yung nangyayari. So you have to present your solution in writing in such a way na madali siyang sundan nung babasa. Alright? So nagmaminus ako kapag hindi ko madaling nasundan yung inyong solution. But most of you wrote it in a very elegant and a very detailed way. So I love that. I hope you keep it up for the midterm, for the pre-final exam. Pero dahil nandito naman ako para sabihin yung mga reasoning behind each lines, so sketch na lang ng solution yung ipapakita ko. Alright? So hindi ko na isusulat yung mga words na katulad ng sinulat ko in our previous example. So para lang mas mabilis. Okay, now first step. First bullet, find the solution to the homogeneous version. So we have d squared plus 1 applied to y. So ang ating characteristic equation ay m squared plus 1 equal to 0. Now, it has solution m equals plus or minus I. So yung characteristic equation may solution of plus or minus I. So therefore, our general solution to the homogeneous GLDE I equals to C1 cosine x plus C2 sine x from what we learned from chapter what? Chapter 3.5 or 3.4? All right. And then we'll keep it aside for later. Okay. Second bullet na. So we want to find a function v of x such that ay kailangan ko palang pumili ng y sub 1 muna, no? Such that, kompletuhin ko na lang to, y sub p equals v times y1. So kailangan kong humanap ng function v such that v times y1 ay magiging particular solution ng GLDE na non-homogeneous, all right? But what is y sub 1? So we will just be choosing a particular y sub 1, a particular solution to the homogeneous GLDE. Ito yung solution natin para sa homogeneous version ng GLDE. Pumili ka lamang ng isang particular case for this one. And in this solution, I will choose, ano nga ba yung ginamit ko kagabi? Ang ginamit ko ay y1 equals sine x. So I chose C1 to be equal to 0 and C2 be equal to 1. Again, pwede nyo tandaan, pag nasa second bullet ka na, lahat ay particular solution lang yung hinahanap mo, pwede kang magbigay ng kahit anong value sa mga arbitrary constants na gusto mo. Alright? So that's why I'm going to choose y1 to be equal to sine x, and the goal is to find a function v such that sine x times v would be a particular solution to the non-homogeneous GLDE. Okay? Tapos, pwede nyo gawin ulit, computein si y prime, si y sub p prime, si y sub p double prime, tapos i-build up yung equation galing dito, plugging in our ansatz for y sub p. Pero kung babalikan nyo yung derivation, balikan ko lang. Kung magaling kayo magsaulo, no? You don't need to show all steps of the solution. So pwede nyo sabihin from the derivation in class or the derivation in the slides, pwede nyo sabihin na ito kagad yung makikita nating form. Copy-paste ko to kasi hindi ako magaling magsaulo. So copy ko yan. Okay. Right. So lagay ko lang. From the derivation in class, if we let v prime equals w, so pag si v prime sinulat nating w, then we'll get this. Alright, so ito yung binigay sa atin ng derivation. But in this particular case, what is our p? So our p here, remember si p ay coefficient ni y prime. Okay. Pero dito, anong coefficient ni y prime? So meron lang tayong y double prime plus y equals cosecant x. Wala kang y prime. Si p ay coefficient ni y prime. So that means p of x is equal to 0. So here, p of x is equal to 0. Madali lang. So, pwede ko agad yung sa derivation na kanina. So, ito yung makukuha natin. y1, remember our y1 is sine x. So, y1 replaced by sine x. Then w prime, yan yung unknown natin ngayon, times w prime, plus si p of x ay 0. So, magiging 2y prime na lamang to, plus 2. Pero ano si y sub 1? Si y sub 1 ay sine x. So, si y sub 1 prime ay cosine x times w equals cosecant x. Okay. So, ang dami nating natipid na lines, alright? So, kung magaling talaga kayo magsaulo, you can do this. Pero if you're like me who, wala ko for a moment there, but if you're like me who hate memorization or cannot stand memorization, so gagamitin niyo yung long method na ginawa ko kanina sa previous example. But if you have access to this, mas madali na. Kasi from here, you'll get this equation kagad. Which is the same thing if you'll do it the long method. Okay? So ngayon, pwede akong mag-divide both sides ng sine in preparation for finding the integrating factor. So this will tell us that we'll have w prime plus 2 cotangent w, cotangent x times w equals cosecant divided by sine. So ito ay cosecant squared. Tapos medyo kakabahan ka na rito kasi may mga trigonometric and expect we will be integrating some trigonometric functions. Okay? So everything's good until this point? Diyan pa ba kayo or na-lost na kayo? All good pa? All right? Talagang kapag nagsasolve ng reduction of order or variation of parameters, kailangan may tubig kang katabi kasi ang daming mangyayari. Alright? Now, we have reduced the order. And the reason why we wanted to reduce the order para madaling mag-compute para pwedeng mag-compute ng integrating factor. So, for this, we'll have the following integrating factor. S of x equals e to the integral kung ano man yung coefficient ni w. So 2 cotangent x dx. Tapos ito na, ano nga bang integral ng cotangent x? So sino nga yung magbibigay sa atin ng derivative ng cotangent? Alam ko to ay ln of something. Ln of something, pag dinifferentiate ko yung ln ng something, dapat makuha ko ay cotangent, so that's cosine x over sine x. So dapat ay meron akong sine x sa loob. Right? Kasi ang derivative ng ln sine x ay 1 over sine x times derivative ng sine x, which is cosine x. So there you go. Ln of sine x. This is e to the ln of sine x plus c. Or lagyan nyo ng absolute value. Now we choose c equals 0 and assume sine x is positive. So we'll get s of x, or integrating factor will be e to the ln of sine x, but that will just be sine x. Isang particular integrating factor natin ay si sine x. Sorry. Nawala yung 2. May 2 nga pala siya sa unahan from there. Tapos papasok siya doon sa loob. So hindi ko na kailangang i-assume na si sine x ay positive. Kasi ito ay pwede kong isulat na e to the ln of sine x quantity squared plus c. I'll just choose c to be equal to 0. Then I'll have this. Thank you, Kiefer. Napansin niya na dapat may 2 pa. So ang integrating factor ko ay sine squared x. Alright? So ang gagawin ko, i-multiply ko ito, both sides, by sine squared 2x. So, anong mangyayari? Let me just copy this. Lipat ako ng next page. Kailangan ko siyang copyhin kasi I have the memory of a goldfish. So, kailangan kita ko lahat ng nangyayari. Alright? So, multiply ako ng sine squared x both sides. So, sine squared x w prime plus 2 cotangent x times sine squared x. Ang cotangent ay cos over sine times sine squared. Maka-cancel yung isang sine. So, we'll have cosine x sine x w. Tapos cosecant squared times sine squared, 1 over sine. Yay! 1 lang yung right-hand side. At least nawala na yung pinoproblema ko pa kanina na cosecant. Alright? Okay lang pala yung cosecant squared. Madali siyang integrate. But it's even better that the right-hand side just became 1. Okay? Tapos the reason why we multiplied both sides by the integrating factor is so that the left-hand side of the equation we have right now will be a derivative that came out of the product rule. Specifically, this is the derivative of sine squared x times w. Pwede nyo i-double check, i-differentiate nyo to para malaman nyo kung tama yung integrating factor na kinuha nyo. Pag differentiate nyo to using product rule, you have sine squared x times w prime plus w times derivative ng sine squared x, 2 sine x cosine x, which is essentially this guy. So we're good. And then we multiply both sides by the differential of x para magkahiwalay na yung dalawang differential. All right, and then we integrate. So we get sine squared x times w equals x plus c. Then we choose again c equals 0 kasi nga nasa second bullet pa tayo. Everything here is a particular solution. So you can give whatever value you want for the constants. So here I'm choosing c equals 0. So I'll have sine squared x times w equals x. Then I'll divide both sides by sine squared x. So that w, eto na naman siya, nagbabalik, x times cosecant squared x. Akala ko nakatakas na ako sa cosecant squared x. All right. Tama ba? Yeah, I think tama naman siya. Dino-double check ko muna kasi mag-IBP ako rito. Kasi magkakaroon ako ng, tama ba? Yeah, W cosecant squared. Yes, because now, remember, we know that we let W to be equal to V prime. So we'll have V prime equals X times cosecant squared X. So that means dV equals X times cosecant squared X dx. This is what I feared. Kasi ngayon si V ay magiging integral ng x times cosecant squared x dx. I need to use IBP. Right? Pero I'll just do it on the side. Kayo na lang yung magpo-formalize. So parang scratch work lang to. Sketch nga lang ng solution. Kayo na yung bahala mag-formalize ng buong solution. Ano? So magta-tabular IBP na lang ako. Ito yung mga U. Ito yung mga V. So ang U ko ay X, yung madaling mag-zero ang derivative. Tapos i-integrate ko naman ay yung V. Alright? So i-differentiate ko lang yung mga U. So I'll have X, derivative niya ay 1, derivative niya ay 0, 0, and so on. Integral ni cosecant squared ay what? Negative cotangent x. Tapos, integral ni negative cotangent ay sine over cosine. Hold on. Double check. Tama ba yung ano? W equals x cosecant squared x, no? Okay, thank you, Kiefer. I think that's this guy. You're referring to this, okay? So tapos i-integrate ko ngayon yung cotangent. Ano ang integral ng cotangent? So I think this is ln ng ano yung madi-differentiate para makuha ko si negative cosine x over sine x kasi cotangent. So dapat ito ay sine. ln ng sine, so 1 over sine, pero ang derivative niya ay cosine. Pero may negative sa unahan. So this would be negative ln ng sine x. And so on. Tapos pwede na akong tumigil dito kasi alam ko nagko-cross product lang ako dito. No? Alternating sign plus minus plus minus. Then this guy times that guy. 0 na siya. Oops, yay. 0 times whatever this is. That's fine. Tapos na yung IBP. Bakit iba yung nakuha kong sagot kagabi? Bakit? Okay. Sinimplify ko na pala siya. I think this is good. So V is then negative x cotangent x plus ln ng sine x plus an arbitrary constant e, but we can choose e to be equal to 0. So we'll have v equals negative x cotangent x plus ln of sine x. So therefore, our y sub p, which is v times y sub 1, will be sine x times v. Okay. Tapos, pwede nyong i-simplify negative x cosine x plus sine x ln ng sine x. And that's our y sub p. Tapos, i-add ko to dun sa homogeneous solution we got from the first bullet to get our general solution to the homogeneous GLDE. Okay. Tingnan natin, eto na siya. Sige. If you want to get a screenshot of this, do so now. Okay. Though again, sketch lang to ng solution. So disclaimer, sketch lang siya ng solution. So kayo na yung bahalang magkwento. Alright? Pwede kong gawin yung ganito na sketch lang kasi andito naman ako para explain yung mga steps. Ano? Pag kayo na yung nagpasa ng problem set, wala naman kayo sa tabi ko para sabihin, sir, ganito yung ginawa ko dyan. So kailangan yung ikwento. No? Unless it's a video problem again. So mas madali pag video problem. Pwedeng sketch lang din yung ipasa nyo. Okay? So I think that's it. And then here's the final solution. Here's our y sub c, the general solution of the homogeneous equation. And this is the particular solution that we got with the second bullet. I-add ko lang yung dalawa, and I'm going to get the general solution to the homogeneous GLDE. Ang haba. All right. Isang oras for 2 problems. but I think that's fine. Any questions about this method? Pero masaya na i-experience nyo itong method na to. That's why, for your 11th homework, eto, pili kayo ng isa sa dalawa na to. So, syempre, pipiliin nyo malamang yung number 1 kasi x minus 1 lang, ano? Pero I dare you to try the second one, cosecant cube. Hopefully, may mga makakancel din naman dyan, ano? So, let's do this as our homework 11. Ang due niya ay November 30th or holiday ng November 30, tama ba? I think November 30 is a holiday. Can somebody confirm kung holiday siya? Holiday siya, no? So, December 1 na to. Ang gandang pasok ng December sa atin, homework agad, no? So, choose one. Tapos, December 1 ang deadline, 11:59 p.m. Okay. So, pili lang kayo ng isa sa dalawa na yan. And I think that's it. That's this section. Alright? Masaya siyang gawin hanggang kaya mo mag-integrate. Ano? Kasi parang straightforward yung process. Mechanical nga siya almost. Ang problema lang, ang daming integration na nagaganap. At madalas mahirap gawin yung mga integration. Kanina nag-IBP pa tayo, ano, tapos may mga integral ng cotangent na lumalabas na madali lang kung take home kasi meron kayong katabing table of integrals. But the problem is, what if it's a sit-in exam na dapat sa ulado niyo yung mga integral na yon. So you need really to remember and to recall yung mga integration and differentiation formulas. Okay? All right, so if there are no more questions about the reduction of order method, we can now go ahead and take a look at a generalization ng method na to. Oops, what happened? Which is basically what we call the method of variation of parameters. Now, instead of assuming yung mga arbitrary constants, magkamukha yung dalawang methods na to. Ang pinagkaiba lang nito ay, di ba, so si y1, pinili natin kanina to be a particular case of the homogeneous solution. Hindi laging nag-work yun. Alright, so di ba meron kang y sub c equals c1 times isang function plus halimbawa c2, another function na nakuha mo sa homogeneous system. Si c1 at saka si c2, binibigyan lamang natin sila ng arbitrary constant values. And then we're hoping that there will exist a v such that v times y1, the chosen y1, is a particular solution. Again, we are hoping that that would be the case, that we will be able to find the v. But there would be instances that we cannot find such a v, particularly if whatever we get as our w prime is not integrable, then wala tayong mahanap na v. So that the previous method can fail. Now, if putting a constant value to the homogeneous, to the arbitrary constants in the general solution of the homogeneous GLD will not work, then why not try a more generic approach? Instead na si C1 at saka si C2 ay piliin natin to be constants, maybe we can vary the parameters. Kaya nga, variation of parameters yung tinatawag. Instead of assuming they are constants para kay y1, piliin ko kaya siya so that si C1 at saka C2 ay functions din ni X. Alright, instead of constants, i-assume ko sila ay mga functions of X. That will give us a variety of choices. Kasi nga baka yung constant hindi siya mag-work. Baka wala tayong mahanap na v such that v times y1 is a particular solution. So what if y1 is chosen to be a more generic one? Instead of replacing c1 and c2 by our choice of constants, baka naman pwede nating palitan yung parameters, or let's vary the parameter from simply being constants to being functions of the variable x. And then from there, maybe, just maybe, we can find a particular solution. And again, I'm praying again that mag-work sana siya. Kasi hindi laging yung ansatz ay natutupad. Remember, yung ansatz, guess lamang natin siya para sa solution. What if our guess was wrong? That there is no such constant. So hanap tayo ng ibang mas general na way. And the generalization of the method of reduction of order is what we call the variation of parameters. Okay. So ito yung tiningnan natin, ito yung kinikwento kanina, ito yung ginawa natin sa reduction of order. But what if instead of looking at this y sub c, ito yung particular solution y sub c natin, y1 plus c2 y sub 2, alright? So ito yung nanggaling sa si y1 at saka si y2 siya yung nanggaling dun sa characteristic equation pag solve nyo nito. So kanina sa variation as a reduction of order, usually si C1 at saka si C2 pinipili ko lang to be 1 and 0 para makakuha ko ng isang specific na Y1. Pero hindi siya lagi mag-work. So the more generic way is to choose C1 is to replace C1 and C2 by functions of X themselves. Okay? So yun yung magiging bagong ansatz natin. So yung bago kong ansatz, sana si y sub p equals this guy, yung a, which is a function of x times y1, plus b, which is a function of x times y2, is the particular solution. I am hoping na isa siyang particular solution nitong non-homogeneous GLT. So basically, ganun pa rin. First bullet, isolve niyo yung homogeneous system o yung homogeneous equation. Tapos ngayon, ang ating particular solution, ang ansatz natin o yung guess natin para sa particular solution ay ay1 plus by2, where a and b are not just constants anymore, but they are functions of the variable x. Okay? So ito yung gusto kong mangyari. Now, plug this in. Compute y sub p double prime and y sub p prime. Plug them into here. So, kinompute ko si y prime. Kinompute ko si y double. Okay. Hold on. Nag-insert pala siya ng shortcut dito. Again, we're looking for particular solutions. So there we have some leeway para piliin sino yung gusto natin na mga constants whenever we have the choice. Or what are the properties that we want to impose whenever we have the choice, right? Well, paano natin pipiliin si A at saka si B? Una, gusto ko dapat, balik ako dito, gusto ko dapat si y sub p of this form, dapat nasa-solve nito. Okay? So it should be a particular solution. So when I plug in y sub b into this guy, I will get an equation that involves A, B, and their derivatives. Okay? But here I have two unknowns. I have A and B. So I can afford to have two equations. The first equation will be dictated upon by this. Yan yung first condition kay A and B. A and B must be chosen such that this is true. But we have two unknowns, right? Isa pa lang yung equation, so free ako na mag-imbento pa ng isang condition that will be convenient for us. Tapos makikita natin mamaya ano yung pinili kong additional condition out of the blue, but the reason why I chose that ay para mapasimple yung calculations. Okay? Now, computing ko yung y sub p prime. Ito yung y sub p natin. Kinompute ko si y sub p prime. Okay? Ito yung makukuha ko. Now, remember, we still have 1 degree of freedom. And look at y sub p prime here. Nag-introduce na tayo ng a prime at saka b prime. But I don't want a prime and b prime to be part of the picture, right? Kasi nga, a and b lamang yung usapan na gusto kong isolve. Now, getting the derivative made it more complicated because here we have a prime and b prime na involved. So, meron akong isang natitirang condition na pwedeng i-impose. Pwede pa mag-impose ng isang condition. And the condition that I'm going to impose is that this term, yung may a prime at saka yung may b prime, i-assume ko out of the blue na equal kay 0. Para wala ng a double prime mamaya. Alright? Kasi remember, kailangan ko pa yung y sub p double prime. So magpa-product rule na naman ako ngayon sa 4 na terms. Magkakaroon na ako doon ng b double prime. Parami na ng parami yung conditions kay b. Pero again, remember, we have one free condition left. Pwede pa akong mag-impose ng isang condition. And I choose that condition to be y1 a prime plus y2 b prime to be equal to 0. Okay? Ano lang to, a capricious choice lang to. Ito lang yung choice ko out of convenience. Okay? Which is fine kasi naghanap lang naman tayo ng isang particular ng particular values para kay A at saka kay B. Hindi natin hinahanap lahat. Naghanap lang ako ng particular solutions. Okay? Now, so masisimplify na si y prime kasi nga may mga pinag-zero ko. But remember this condition. Gagamitin natin yan mamaya. Kasi magsasolve ako mamaya ng system of equation. So that should be there. And then here I have y prime. Tapos ito ng simplified version kay y prime yung gagamitin ko to compute y double prime. So kinumpute ko si y double prime using this. Pero ngayon inevitable na meron akong a prime at saka b prime. Okay? Tapos hindi na ako pwedeng magbigay ng condition. Kasi dalawa yung hinahanap ko, right? Naghahanap tayo ng a at saka b. Naghahanap ako ng A at saka B. Dalawa yung hinahanap ko na unknown, so I can afford to impose two conditions. Meron na tayong isang condition galing dun sa non-homogeneous GLDE. Ito yung second condition na inimpose ko, so wala na ako may impose pa or wala na akong free na imposition na pwedeng ibigay. Kasi pag nagbigay pa ako ng isang imposition, posibleng wala nang solution akong makuha. Alright? So, talina yung kamay natin ngayon. So, I don't have any choice but to plug in the y sub p prime and then the y sub p that we have in this equation. Na-plug in ko dyan yung mga derivatives na na-compute natin. So, we do so. So, ito si y sub p double prime, ito si y sub p prime, ito si y sub p. Alright, ito yung hula natin kay y sub p. And then, but here we can what do you call this? We can group some terms. In particular, group it this way. So, pwede kong i-factor, i-grupo lahat ng may A at saka lahat ng may B. And luckily, lahat ng may A at saka lahat ng may B ay pwede kong i-factor this way, respectively. And then, plus, ito yung mga walang A nor B. Now, what can we say about this? And this guy. Ano nga si y1 at saka si y2? Si y1 at saka si y2 ay mga particular solution ng homogeneous equation, right? Kasi ang y sub c natin ay c1 y1 plus c2 y2, right? So si y1 at saka si y2 ay mga solutions ng homogeneous equation. So that means this guy is equal to 0. This guy is equal to 0. Lucky for us, all right? Kasi nawala na yung masyadong maraming expressions na nangyayari. Okay? Dahil nag-zero yan, natitira na lamang ay etong condition na to. A prime y1 prime plus b prime y sub 2 prime ay equal kay r of x. Okay? That's what we have here. So essentially, ano dapat yung nasa-satisfy ni A at saka ni B? A and B must be chosen such that this is true. Ito yung nanggaling mula dun sa non-homogeneous GLDE. Okay, so yan. Tapos, saan nanggaling itong isang equation to? Yung una. Ito yung nanggaling dun sa ating additional condition na inimpose. Remember, sabi natin, para mas simple yung y sub p prime, gusto natin yung a prime y1 plus b prime y2 ay equal kay 0. Ngayon, ito yung system of equations na kailangan nating isolve para mahanap si A at saka si B. Okay? I'm thinking if I have time to finish this, maybe if you can lend me 5 minutes or 10 minutes, so pwede natin itong matapos. Kasi mag-start pa ako dito next meeting. So if you have to go early, so you can just make sure to watch the recording kasi i-discuss ko na yung solution. Alright? Pero essentially, itong method of variation of parameters, kailangan nyo lang isolve itong system na to. Can do elimination, you can do Cramer's rule, So just review how to solve for linear equations, systems of linear equations. Nag-work pa rin naman yung mga methods na ginamit natin for for equations na constant yung coefficients, pagka yung mga constants na ay hindi na basta-basta coefficients. Okay? Basta tandaan nyo lang ito. Ito yung ifo-form natin na system of linear equation. Yeah, we can forget about this. It's just a check kung kailan magkakaroon ng solution. Magkakaroon ng solution etong system na to kapag yung Wronskian ay hindi equal kay 0. Meaning kasi ito yung mga coefficients natin na known. Pag kinuha mo yung determinant niyan, meaning yung product pababa minus the product pataas, kapag yan ay hindi 0, ibig sabihin may makukuha kang solution. But again, we can just continue and just perform and just attempt to solve the system, all right? Para malaman nyo kung may solution or wala. Additional step pa kasi itong pag-check muna kung may solution or hindi. Why not try to solve it para malaman mo kung may solution or wala? Madali lang naman to, 2 by 2, so usual elimination might work for this. Pero siguro, next time ko na ituturo, one more example on Friday, kung ano yung mangyayari kapag hindi mag-work yung elimination method. Okay? Or I'll double check if we will encounter such cases. Pag hindi naman, I'll just give it as a reading assignment. Okay? Now, to make sense of this method, mag-solve tayo ng isang particular example. Copy-paste ko lang tong copy ko lang tong system na to kasi yan yung bubuuin natin mamaya. Okay. Now, let's try to solve d squared plus 1 applied to y equals secant x tangent x. Again, hindi mag-work yung method of undetermined coefficients kasi secant x tangent x yung nasa right-hand side. Wala tayong alam na GLDE with constant coefficients na ang solution ay secant x tangent x galing sa kanyang characteristic equation. So kailangan humanap kayo ng ibang method. Now, we'll use the variation of parameters for this one. Pero in any case, we still need to have the homogeneous solution. Okay? Now, sketch na lang uli na. Sketch ba? Hindi. Isulat ko yung buong solution. So, let's call this star. Okay. So, the characteristic equation for the homogeneous version of equation star is m squared plus 1 equals 0 with solution m equals plus or minus I. So therefore, ang y sub c natin ay c1 times cosine x plus c2 sine x. Now at this point, you can try reduction of order. I don't know if reduction of order will work. Pero hindi ko siya tinry i-solve. Pero you can try to see if the method of reduction of order will apply. Okay? Pero ididiretso ko na to na variation of parameters. So essentially, what I want here to happen is that so I will let y1 to be cosine x and y2 to be equal to sine x. And we wish to find functions a of x and b of x such that the following are true. Ito yung gusto nating masatisfy ni capital A at saka ni capital B. All right? So I'll just contextualize it in the in our case or in our problem. So I'll have a prime times y1, so that's going to be cosine x plus b prime times sine x equals 0. And then I'll have a prime times y sub 1 prime. Y sub 1 prime. My y sub 1 is cosine x. So this will have negative sine x plus b prime times y sub 2 prime. My y sub 2 is sine x. So this would be cosine x equals 0. Sorry, not 0, but equal to r of x. Our r of x is secant x tangent x. So ito ay equals secant x tangent x. Ito yung system of equation na gusto nating i-solve. All right. Now, how do we solve this? You can use Cramer's rule, you can use substitution, but here I'm going to use elimination. Okay? Gusto kong mag-eliminate ng variable. Again, the unknowns here are a prime and b prime. So, pwede kong i-multiply yung yung both sides ng equation, ng first equation by what? By sine x. And then multiply both sides of the second equation by cosine x para makancel yung may a prime. Kasi ito ay magiging a prime times sine x cosine x. Ito ay magiging negative a prime times sine x cosine x. So magka-cancel sila pag in-add ko. So let's call this equation 1, equation 2. So we multiply both sides of 1 by sine x and of 2 by cosine x, then add, we'll get the following. So ito ay yan, nawala yata ako ron. So yung first equation na multiply ng sine, so we'll have b prime times sine squared x. Tapos ito, na multiply ng cosine. So we'll have plus b prime cosine squared x. Tapos in-add natin, no, para makancel yung may a prime. So equals 0 plus, ito ay na-multiply ng cosine. Pag na-multiply siya ng cosine, ito ay sine over cos. So may multiply siya ng cosine. Sine secant. Tama ba? Sine secant. Bigla ako na blanco sa trigonometric, ano. So i-multiply ko to ng cosine. So times cosine x. So secant ay 1. Secant ay 1 over cosine. So maka-cancel. So tangent lang yung matitira rito. Tama ba? Tama, no? Tangent lang yung matitira. Bakit bigla ako na blanco ron? All right. So essentially now, but here I can factor out b prime. So I'll have b prime times sine squared x plus cosine squared x equals tangent x. Trigonometric identity, the Pythagorean identity, sine squared x plus cosine squared x is equal to 1. So we'll have b prime equals tangent x. Pero ito ay b prime. So we need to solve for b. All right? So integrate ko na lang naman to get b, right? So take your screenshots before I go to the next slide. I-solve ko ngayon kung ano si b. Alam ko na si b prime ay tangent x. Okay? So si b prime ay tangent x. So therefore, si b ay integral ng tangent x dx. Alright? So kailan ako magkakaroon ng tangent na derivative? Ang tangent ay sine over cosine. So ln yan. Alam ko ln yan eh. ln of what? Dapat magkaroon na ng cosine x. Kasi ang derivative ng ln cosine x ay 1 over cosine x times derivative ng cosine, negative. So kailangan may negative sign sa unahan. Okay. So this would be negative ln ng absolute value ng cosine x plus c. Right? But again, we are looking for a particular solution. So we can choose c to be equal to 0 kasi particular b lang yung hinahanap ko. Hindi ko hinahanap lahat ng posibleng b. Naghahanap lang ako ng isang particular na b. Alright? So here, I'll choose c equals 0 so that I'll have a simpler b, which is ln ng, para mawala lang yung negative, pwede ko itong isulat na cosine to the negative 1. So ito ay magiging ln ng secant, absolute value ng secant x. Alright? Tapos ngayon, hanapin na natin si A. Now, ano yung equation na meron tayo? Balik ako dito. Gamitin ko yung first equation to find A prime. Ang B prime ay tangent. Okay. So, from equation 1, base ko sa equation 1, ito sa equation 1. Tapos plug in ko na yung alam natin na value ni B prime. So we'll have A prime times cosine X. Alam natin si B prime ay tangent X plus tangent X sine X equal kay 0. So magkakaroon ako ng sine squared. So essentially, I'll have A prime cosine X equals negative tangent X sine X. Then I'll divide both sides by cosine. So A prime will be negative tangent squared X. Tama ba? I want to be extra careful with trigonometric functions here. So tama, no? A prime ay negative tangent X. Hindi siya magandang balita kasi ngayon, meron tayong even power ng tangent. But remember, this is A prime. So I need to solve for A. A will be the integral of negative tangent squared X dx. Para dito, kailangan kong i-note na si tangent ay may even power. If you remember from Math 37, techniques of integration, kapag ka-even yung power ni tangent, pwede kang gumamit ng trigonometric identity, the Pythagorean one relating tangent to secant squared. Kasi pag may secant squared ka ng integral ng secant squared ay tangent lang. All right? So essentially, I'll write this as 1 minus secant squared x dx. Kasi ang tangent squared ay secant squared minus 1. May negative ako sa harap, so magiging 1 minus secant squared. Then I'll integrate this. I'll get x minus tangent x plus an arbitrary constant e. So we choose e to be equal to 0 because, again, we're just after a particular value of a. So we'll get a equals x minus tangent x. So therefore, our particular solution is a x minus tangent x times y1. Ano nga yung y1 natin? Ang y1 ko ay cosine, ang y2 ko ay sine. So y1 cosine plus b. Our b is, ano nga si b? Si b ay ln secant x times sine x. Yan yung y sub c natin. Ito yung y sub p natin. Okay. So you want to get a screenshot, but again, this is just a sketch. Hindi ko na sinulat yung buong solution. So kayo na lang yung mag-formalize. If you want, you can try this. You can solve it on your own. Mamaya, pagkatapos ng klase, if you have a free time, try to recreate the solution the way you understood it. And then compare nyo yung nakuha nyo with what I got. If you got stuck in one of the steps, just go back to my solution or to the one uploaded in the slides. So, ganon. Parang ganon yung madaling paraan para matandaan nito. Right? Tapos nakuha na natin yung particular solution. Lucky tayo kasi nag-pay off yung ating ansatz. Yung ansatz natin na a times y1 plus b times y2. It got us a particular solution to the GLDE, to the non-homogeneous GLDE. And that was obtained by just solving this system. You know? So we're now ready to conclude that our solution is y sub c plus our particular solution. Tama ba? Ito ba nakuha natin? Kasi nag-tangent cosine lang ako. But negative yun. Negative sign ba yun? Okay. That's right. So, yeah. You'll get this one after simplification. Nag-cancel lang dito yung may sine, yung may cosine saka yung tangent. Okay. And I think that's it. We're done. Parehas din pala to. Okay. Dun sa homework nyo, dun sa homework 11, so you can either choose variation of parameters or you can use the method of reduction of order. Okay. So babaguhin ko na lang yung instructions. So Pwedeng variation of parameters or pwedeng reduction of order yung gamitin. Kung alin yung mas madali sa tingin nyo. At mukha naman mag-a-apply siya parehas kasi parehas sila na nandito sa exercises. Ano? Pero mas generic kasi or mas malaki yung chance na may solution yung variation of parameters. Kasi mas generic dito. Hindi lang arbitrary constants yung pinipili natin for C1 and C2. We are replacing them by arbitrary functions. Okay? And I think if the variation of parameters will work, automatically the method of reduction of order will work, but not the other way around. Pwedeng yung variation of parameters ay baliktad pala. Pagka nag-work yung pag nag-work yung reduction of order, sure tayo na mag-work yung variation of parameters. Pero pag nag-work yung variation of parameters, hindi necessary na mag-work din yung reduction of order. Kasi yung reduction of order ay specific case lamang ng variation of parameters. Kasi baka yung ansatz natin mula dun sa reduction of order ay hindi sa atin magbibigay ng desired function. Okay. Pero yung variation of parameters, mas generic yung ating ansatz. Mas maraming choices. And the more choices you have, the more chances of winning. So, kaya mas generic yung variation of parameters. Okay. And I guess the way I presented it, variation of parameters is much simpler than the method of reduction of order. Ang ano nga lang dito, ang catch nga lang dito, kailangan mag-solve kayo ng system na to. All right? Lucky for us, the system is relatively easy to solve here kasi ang method ko lang na ginamit ay elimination. If you will go to the handout that I uploaded, ang ginamit niya ay Cramer's rule. I don't know if you guys heard of Cramer's rule. Ito yung gumagamit siya ng mga determinants. Yun yung ginamit dun sa slides. So if you're curious upon the Cramer's rule, so go to the handout that I uploaded. Nilipat ko na siya. Nasa week 12 module na siya. But that's the same set of slides that we have for week 11. Tinanggal ko lang siya sa week 11. Nilipat ko siya sa week 12. Pero yon, a different flavor to solving this system. Gumamit siya ng Cramer's rule, wherein I just use plain old elimination method. Okay? So I'm sorry I went 13 minutes over time, but I think it's worth it. At least natapos na natin yung part na to ng I think we're done with section 3.6. So on Friday, we'll start with section 3.7, linear operators, all the way until inverse linear operators. Okay? And yan, malapit na tayong matapos. So, any questions? A reminder lang, parang meron kayong homework due tonight, no? Tama nga ba? I guess your reaction video is due tonight. So make sure you do that. And I guess we have another homework which is due next week nga ba or this week? I'm not sure. Just double check our deadlines in Canvas, all right? So with that, guys, I will not keep you long. Medyo dinelay ko na kayo ng konti. Thank you for staying, and let's see each other again on Friday. Okay? Bye, guys.
Thank you, sir.
All right.